Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as surface tension. Now, let's try to understand what is surface tension. What do we understand by surface tension? Now, the free surface of a liquid behaves like a stretched membrane. Suppose if I have a beaker in which I have some liquid. Now if I keep some small object on it, that object would float on the surface of the liquid. Why would it float on the surface of the liquid? Because the surface of the liquid would behave like a stretched membrane, and this property possessed by liquids to where the surface behaves like a stretched membrane is called as surface tension. It is because of this property that you have small objects that can float on water, right? Even if the density of the object is greater than that of water, it does not sink, but its weight is balanced by the tension that is acted by the stretched membrane. Right? So just let's write this down. What is surface tension? The free surface of a liquid behaves like a stretched membrane right? All liquids possess this property. Surface tension. So surface tension is a property wherein the surface of the liquid behaves like a stretched membrane, right? Even if the density of the object is greater than the density of the liquid, if the density of the object is greater than the density of the liquid, it does not sink, but its weight is balanced by the tension. It does not sink, but its weight is balanced by the tension. Its weight is balanced by the tension acting tangentially to the concave surface of the liquid. Acting tangentially to the concave or convex surface of the liquid. Fine. Now, that which clearly shows that the surface of the liquid is always under certain tension, right? Now, the shape that is going to be taken by the liquid is going to have it is going to take a shape wherein it has a minimum surface area, that is minimum energy on the surface. This is because the system possessing minimum potential energy tends to be more stable and contracts, right? So hence the surface of the liquid will never be straight, but in order to have more stability, it is going to have minimum surface area, and to have minimum surface area, it is going to have this tendency to bend. It will have minimum surface area so that it can have minimum energy and more stability. In order to have that, there is going to be a tendency to have, there is going to be a tendency of in the liquid to stretch. See, I'll write this down and show you. liquids always have a tendency liquids always have a tendency liquids always have a tendency to take the shape in which it has minimum surface area. Right? Minimum surface area, that is minimum energy on the surface. That is minimum energy on the surface. Right? So as a result, this is the reason for the spherical shape of the liquid drops. Now, I can say that any system possessing minimum potential energy always tends to be stable. This is because any system possessing minimum potential energy tends to be stable, and that is the reason for the spherical nature of the liquid drop. This is the reason for the spherical nature of the liquid drop. Fine. So as the liquid surface thus tries to contract so that it possesses minimum surface area and tends to be stable, this tendency of the surface area of the liquid is due to the property of surface tension. So you will always have the surface of area of the liquid which will try to contract so that it can have minimum energy, and this tendency to contract is because of the property that is possessed by all liquid, which is called as surface tension. Fine. So I can say that this tendency to contract, the surface area of the liquid, this tendency to contract the surface area of the liquid is due to the property called surface tension. Fine. So do we understand the concept of surface tension? Right? The surface tries to contract so that it possesses minimum surface area and becomes more stable. The surface tries to contract so that it possesses minimum surface area and becomes stable. Right? That is the concept of surface tension. Fine, do we get this thing clear? Now, let's therefore find out the forces that give rise to surface tension. Now, surface tension, let's try to understand surface tension on the basis of molecular model or on the basis of molecular theory. Let's assume I have a beaker filled with liquid. Now, first of all, before we start with surface tension, let us see what are the different types of forces that exist in nature. First, you have cohesive forces. Two molecules of the same substance exert a force of attraction on each other, which are called as cohesive forces. Thus, two molecules of liquid will attract each other because of this property called as cohesive forces. Now, besides cohesive forces, the other forces that are present is adhesive forces. What are adhesive forces? It is a property due to which two molecules of different substances attract each other. There will always be a force of attraction between two molecules of different substance, and that property is called as adhesive forces. Now, let's try to now both these forces, cohesive and adhesive forces, are short range forces. They act in a very small distance. Okay. Now let us try to see a water molecule inside the water. Let's consider this is the water molecule A inside the water. Now, water molecule A inside the water is going to experience a force from all the directions. It is going to experience a force because you have water all around. So, it is going to experience a force of cohesion from all the directions. Since it is going to experience a force of cohesion from all the directions, the net force acting on this body, on this molecule A, which is inside the surface of the liquid, is going to be zero, and hence the molecule will remain in its own position. Let us consider a molecule B which is close to the surface. Right? If I consider a molecule B which is close to the surface, you will see that due to its sphere of influence being close to the surface, there will be more force that will be acting in downward direction rather than in upward direction. There is going to be more net force acting in downward direction. There is less net force acting in upward direction. Therefore, there will be a tendency for this molecule to move in downward direction. Right? Let us consider a molecule on the surface of the liquid. If I have a molecule on the surface of the liquid, there will it will have only half of its sphere of influence, which will be underwater. Therefore, there will be forces, the force of attraction will be acting only in downward direction. The cohesive forces will act only in downward direction, and therefore there will be no cohesive force acting in upward direction, as there is no sphere of influence above the given liquid molecule. Right? As a result, there will be a tendency for this molecule to move below. Right? This causes the surface of the liquid to contract, because the molecules which are on the surface will have a tendency to move down, which will cause the surface of the liquid to contract, which gives rise to the phenomena of surface tension. Do you understand why the phenomena of surface tension arises on the basis of molecule of water? Let's write this down first. Right, there are two types of forces. There are two types of forces acting between molecules. First, cohesive forces. Right? What are cohesive forces? Cohesive forces are the attraction between two molecules of the same substance. The attraction between two molecules of the same substance two molecules of the same substance is called cohesion. And the force is called cohesive force. Fine. So it is appreciable when the distance between the two molecules is very small. This force is appreciable when the distance between the two molecules is very small. When the distance between two molecules is very small. So that's the first kind of force that exists in liquid. The other force that exists in liquid is adhesive force. What is adhesive force? Adhesive force is the force of attraction between two molecules of different substances. Attraction between two molecules of different substances is called adhesion, right? And the force is called as adhesive force, and the force is called adhesive force. Fine. Now let's see this. Both cohesive and adhesive forces are short-range forces and are effective over short distances. The maximum distance between two molecules up to which these forces can act is called as the range of molecular attraction. Both these forces are short-range forces. The maximum distance between the two molecules up to which these intermolecular forces act. Intermolecular forces are effective is called as the range of molecular attraction. Called range of molecular attraction. Okay. Now let's say consider an imaginary sphere around a molecule. Consider an imaginary sphere around a molecule with its radius equal to the range of molecular attraction. That means this will be the distance under which the cohesive and the adhesive forces will act. Such a sphere that is around the molecule which has a radius equal to this range of molecular attraction is called as the sphere of influence. So I can say such a sphere is called sphere of influence. Right? Now, let's consider three molecules A, B and C as shown in the figure. Consider three molecules A, B and C. Right? Now the molecule A is well within the liquid, molecule B is just near the surface of the liquid, and molecule C lies on the surface of the liquid. Molecule A lies well within the liquid liquid molecule B lies close to the surface of liquid and molecule C lies on the surface. Right? Now, in this case, since the sphere of influence of molecule A is wholly inside the liquid surface, therefore, the liquid molecules will be symmetrically distributed around molecule A. Hence, molecule A is going to be equally attracted in all the directions, and therefore there will be no resultant intermolecular force acting on it. Since the sphere of influence of molecule A, since the sphere of influence of molecule A lies wholly inside the liquid, surface, the other molecules are symmetrically distributed around it. The other molecules are symmetrically distributed around it. Distributed around it. Right? The other molecules are symmetrically distributed around it. Therefore, molecule A is equally attracted in all the directions. Molecule A is equally attracted in all directions, and the net resultant, and there is no resultant intermolecular force acting on it. Molecular force acting on it. This is molecule A. Now let us consider molecule B. I can say molecule B lies just inside the liquid surface. Right? The distance between the range of molecular attraction from liquid surface, molecule B lies just inside the liquid surface. Liquid surface. Now, since molecule B lies just inside the liquid surface, therefore I can say a part of sphere of influence of molecule lies outside the liquid surface. Therefore I can say a part of sphere of influence of molecule B lies outside the liquid surface. Right? Now, this part of the sphere which lies outside the liquid surface contains air molecules. This part which lies outside the liquid surface contains air molecules. Right? Now, but their number is very small, hence the force of attraction exerted by them on molecule B is almost negligible, but their number is very small and the force of attraction exerted by them action exerted by them on molecule B is negligible. Right? Hence, I can say that in comparison to the downward force exerted by the sphere of influence to those exerted by the liquid molecule, to those exerted by liquid molecule in the sphere of influence, liquid molecules in the sphere of influence hence, I can say that the result is that the resultant downward force acts on molecule B which tries to pull it inside the liquid surface. The resultant, therefore, the resultant downward force, the resultant downward force acts on molecule B, acts on molecule B and tries to pull it inside the liquid and tries to pull it inside the liquid. That's the reason why a molecule close to the surface has a force that will pull it inside the liquid. Now let's consider molecule C. Consider molecule C. Now I have molecule C on the liquid surface. Molecule C lies on liquid surface. Right? Hence, the lower half of the sphere of influence lies inside the liquid, whereas upper half of the sphere of influence lies outside the liquid. Lower half of sphere of influence lies inside the liquid, while the upper half lies outside the liquid. Right? The lower half lies inside the liquid, whereas the upper half lies outside the liquid. Hence, only half of the sphere of influence which lies outside the liquid contains air molecules, which are extremely small in number as compared to liquid molecules. Therefore, half the sphere of influence which lies outside, half the sphere of influence which lies outside contain only air molecules which are less or extremely small in number, and which are extremely small in number, and as a result of which, as compared to the liquid molecules, as compared to liquid molecules, right? As compared to liquid molecules, which act in, and as compared to the liquid molecule, as a result, you have maximum force which acts in downward direction, and therefore it is pulled inwards with maximum force. As a result, there is maximum force which acts in downward direction and the molecule is pulled inwards, and the molecule C is pulled inwards, right? So those are the forces that are going to be acting on the molecule. Now, as a result, you will see that the liquid molecules which come onto the surface will have a great force that will pull them inwards. This increases, in order to have the same number of molecules on the surface, this increases the surface area of the liquid, and the molecules from inside the liquid must be brought back to the surface of the liquid, because any molecule that tries to come on the surface is going to experience a downward force. In order to have same number of molecules on the surface, you have to have molecules from inside the liquid which should be brought onto the surface, and thus some work must be done against the inward pull. This work which is done is going to be stored in the form of some energy, and that in the form of some potential energy, and that energy brings about surface tension, right? So some work has to be done against the inward force to bring the molecules onto the surface, so that you have requisite number of molecules on the surface, and this work gives rise to certain energy, potential energy, which is stored onto the surface of the liquid, and that is called as your surface energy. Fine, do we get this thing clear? Now, for increasing the surface area of the liquid, molecules from inside the liquid must be brought to the surface. Molecules from inside the liquid must be brought to the surface. So I need to have these molecules that have to be brought to the surface. Now during this process, work is done against the inward pull exerted by a liquid molecule. During this process, work is done. During this process, work is done against the inward pull. The inward pull exerted by liquid molecules. Right? This work done is stored on the surface of the liquid in the form of potential energy. This work done is stored on the surface of the liquid in the form of energy. Right? This increases the surface area of the liquid and increases the potential energy of the liquid. Right? On the other hand, decrease in surface area of the liquid would decrease the potential energy. Right? Now, in order for the body to remain stable, the body should have minimum potential energy. Therefore, the free surface of the liquid always has a tendency to contract, so that its surface area becomes minimum and the surface energy becomes minimum. And this behavior of minimizing the surface area gives rise to the phenomenon of surface tension. Now, as the molecules are moving down, some work is going to be done to bring them up. Hence, there is going to be some energy on the surface of the liquid. Now, I can say that this is stored on the surface of the liquid in the form of energy. This increases the surface area. This increases the surface area and the potential energy of the liquid. right? Now, a decrease in surface area would decrease the potential energy. A decrease in surface area would decrease the potential energy, right? So I can say that in order for and make the body more stable and make the body more stable, hence there is a tendency in the liquid, hence the free surface of the liquid, surface of the liquid has a tendency to contract, so as to possess minimum surface area and minimum energy. Has a tendency to contract so that it can possess minimum surface area and minimum energy. This behavior of the liquid gives rise to a phenomena called as surface tension. This behavior of liquid gives rise to a phenomena called surface tension, right? That is from where you get surface tension, right? So the forces due to the surface tension will act tangentially to the liquid surface so that they can minimize the surface area and attain stable condition, right? So that is your molecular theory of surface tension. I can say that the forces due to surface tension act tangentially to the liquid surface and they minimize the surface area so as to attain stable condition. Right? So that is your entire concept of surface tension. Right? Do we understand how surface tension is produced? Right? Okay, we'll stop this here for the day. Thank you very much.